Hello.
Hello.
Suraya madam.
Sir.
Yes, madam.
Shall we start, sir?
Good morning.
Madam, good morning, madam. Madam, good morning, madam. Sujata, madam, good morning.
Good morning.
Good morning, madam. Sir Muruganatham, sir, good morning. This is Principal Dr. D. Venkatesh, Gates Institute of Technology, sir. Hearty welcome, sir.
Good morning, sir. Good morning.
Sir, good morning, sir. Madam Suraya, madam.
Sir.
Can we, ma'am?
Yes, sir.
Yes, ma'am. Please, ma'am.
Yes, sir. Distinguished keynote speakers from esteemed institutions, delegates, colleagues, ladies and gentlemen, a very good morning to one and all. On behalf of Electrical Engineering Department, Gates Institute of Technology, I, Dr. Syed Suraya, Associate Professor, Department of EEE, delighted to welcome you this morning to online faculty development program on recent advances in electrical engineering. Thank you for being here on this virtual platform and for bringing your energy, ideas, and expertise. I welcome all eminent speakers of our program who are expertise in their areas and for having accepted our request to share their knowledge with all of us. I welcome our correspondent Madam Srimati V.K. Padmavathamma Garu, Managing Director Sri Raghunath Reddy Garu, our Director Srimati V.K. Srivani Garu, and our beloved Principal Dr. Venkatesh Garu, and today's chief guest, Professor Sujata Madam, Principal JNTU College of Engineering, Anantapur, for giving their valuable time for us in spite of their busy schedules. Now, I would like to introduce our institute and the Department of Electrical and Electronics Engineering. Gates Institute of Technology is established in the year 2001, approved by AICTE, and has permanent affiliation to JNTUA and got accredited by NAC. Gates Institute is started with a commitment to bring quality technical education opportunity to the doorsteps of the youth of backward region of Rayalaseema under the aegis of G. Raghunath Reddy Educational Trust. The institution is headed by Dynamic Managing Director Sri G. Raghunath Reddy Garu, Correspondent Srimati V.K. Padmavathamma Garu, who are the heart and soul of this institution, and also Director Srimati V.K. Srivani Garu, who is giving a new direction to the institute. Progressive thinking of our late correspondent Sri V.K. Sudhir Reddy Garu has made Gates stand tall as one of the very first and very few educational institutions to completely run on solar power. The entire institution, including labs and hostels, have uninterrupted power supply because of this solar plant. The Department of Electrical and Electronics Engineering was established in 2004 with an intake of 60 and which was increased to 120 in 2012. Department is permanently affiliated to Jawaharlal Nehru Technological University, Anantapur. The department's aim is to train the students in contemporary knowledge and innovative skills, both functional and integrative, in the discipline of electrical and electronics engineering. The department focuses on The department has well-qualified, dedicated, and experienced faculty and committed supporting staff. We have an MOU with Village Energy, an Australian-based company, and to our credit, 2 DST projects with 79 lakhs got approved. I hope you all will have a stimulating and productive program over the next 5 days. We have eminent speakers for all the 5 sessions from different parts of the world. I would also like to appreciate the questions put forth after the completion of this session in the chat box, and hence all the questions shall be answered. I'll conclude my address with an additional call to all of you for active participation during all the sessions. Now, I would like to request our HOD, Mr. M. Parimesh, convener of this FDP, to address the gathering. Thank you.
Thank you, madam. Good morning, everyone. I welcome you all for this online faculty development program on recent advances in electrical engineering. This is M. Paramesh, HOD of Electrical and Electronics Engineering, Gates Institute of Technology, Gutti, and convener of this FDP. The main objective of this FDP is to know the recent advancements in the field of electrical engineering and to make sure we as a faculty impart and share our knowledge to our students who are our future generation. As we all know that the demand for global electricity is increasing and growing nearly twice as fast as the overall demand for energy. Energy conservation, customization, and control has been inevitable to keep the world running economically. Electrical engineers face mounting challenges to provide solutions in sustainable and smart energy sectors. The share of renewable energy sources in meeting global energy demand is expected to grow by 1/5 in the next 5 years to reach 12.4% in 2023. Renewable energy sources will have fastest growth in the electricity sector, providing almost 30% of power demand in 2023, up from 24% in 2017. The need of the hour is to find the alternative solutions for the increasing rate in fuel cost in India faces every year and the energy conservation. Introduction of electric vehicles to Indian market has been considered as feeder to cap of energy sector. Another development in the field of electrical engineering is the replacement of charging system by batteries in small devices. Wireless charging has been made familiar to many devices, which eliminate use of charging ports and power supply. The challenging factor of wireless charging is to extend the range and capacity of charging, which can apply for variety of IoT power devices. Living with no electricity would be unimaginable, as we cannot realize how many items in this world rely on it to function. Electricity managed energy conserved technologies with sustainable solutions supply as with everything we require to lead bright future for upcoming generations. So keep this keep this as our main objective. We have come up with this FDP and hope we fulfill our objective and reach our outcome. Thank you.
Thank you, sir, for giving introduction and making us aware about the objective of FDP. Now, I would like to request our Honorable Correspondent Srimati V.K. Padmavatama Madam to speak few words.
Okay.
Good morning to everyone. It gives me immense pleasure to see the teaching faculty being connected through this platform. I, V.K. Padmavatama, correspondent of Gates Institute of Technology, Gutti, congratulate the EEE Department of Gates Institute of Technology for organizing this online faculty development program on recent advances in electrical engineering. I thank Professor Sujata Garu, Principal JNTUA College of Anantapur, for accepting as a chief guest on this inaugural session and motivating the participants of this program. I also thank for her beloved advisor and the previous academic director also. I also thank for that also. I also thank all the eminent speakers from India and abroad for accepting the invitation to share their knowledge. I also thankful to the Dr. B. Burunathan sir for the today's speaker. And this kind of platform provides educators, faculties, and researchers to improve the quality of education and imparting the same to the next generation. I wish all the participants will make best use of this program to learn and equip themselves to provide good research and quality education. All the best for all the participants in this event. Thank you all.
Auntie, namaste, Auntie Baunara. Auntie, good morning, Auntie Baunara.
Surya madam.
Okay, ma, go ahead. Okay.
Hello,
Madam, Surya madam.
Sujata. Hello.
Auntie, good morning, Auntie. బాగున్నారా?
Good morning, Amma. Good morning.
ఓకే ఆంటీ.
Amma. Good.
మీరు ఫోన్ చేస్తే మిమ్మల్ని ఒకసారి చూస్తాం ఆంటీ. ఓకే మా. సూర్య, గో అహెడ్ అమ్మా.
Yes, ma'am.
Okay, Ma. Thank you, Ma. All the best for the event.
థ్యాంక్ యూ.
And you, Ma.
Thank you.
Okay.
Thank you, ma'am. Thank you, madam. Sure, we'll try to make best use of this program to improve our skills. Now, I'd like to request our beloved principal, sir, Dr. D. Venkatesh, to speak few words.
Respected chief guest of today's function, Professor P. Sujata madam, the principal, JNTUA College of Engineering, Anantapuram. Resource person for today's program, Professor Muruganatham Balakrishnan sir, Professor and Registrar, MAM College of Engineering. Honorable correspondent of the institution, Srimati V.K. Padmavati madam, the dynamic managing director of the institution, Shri G. Raghunath Reddy sir, respected director Srimati V.K. Shrivani madam, head of the department Mr. Parmesh, coordinator Mr. Shiva Reddy, all the faculty members, and the participants from the different universities and colleges. A warm welcome to the 5-day online faculty development program on recent advances in electrical engineering, organized by Department of Electrical and Electronics, Gates Institute of Technology. A warm welcome to this faculty development program. First of all, my sincere thanks to Professor Sujata madam for accepting our invitation and to be the chief guest for today's program. Thank you very much, madam. Nowadays, we are facing so many problems related to the power supply we are going to use in our daily life. And especially this electrical engineering stream is coming out with a different solution as a substitution for a traditional energy. That they are generating the green energy, solar energy, wind energy to daily use. Not only in this area, and the recent Russia and Ukraine war has taught a lot to usage of the fuel. The best solution for this traditional usage of the fuel is we are going with the solar energy, and that one we are using the hybrid vehicles. Not only the hybrid vehicles, nowadays the recent advancements, we are using the electrical vehicles in place of the traditional fuel energy vehicles. By using this one, we are going to save the environment. We know the importance of environment. If the environment, we are not going to save the environment, it is going to harm the health of the so many people. Already we have seen the corona problem and all. So these things are leading to the oxygen, and we need to protect the environment, that is the trees. To protect this one, we have to go with the solar energy. It is a simple example I am quoting. Whereas we have so many examples like that. So my hearty congratulations to Department of Electrical Engineering for taking such a beautiful topic as a faculty development program, because the power of electricity we need to demonstrate to the present generation. So thank you everyone for giving me this opportunity. Thank you everyone.
Thank you, sir, for your inspiring and motivating words. Now it's time to introduce today's chief guest. I am extremely overwhelmed to get this opportunity to introduce our guest of honor, Professor Sujata Madam, Principal JNTUA College of Engineering, Anantapur. On behalf of my team, I welcome our chief guest, Professor Sujata Madam, who is a principal of the most renowned institution, JNTU College of Engineering, Anantapur. She is the first female principal of JNTU. We are grateful to her for accepting our invitation and becoming a chief guest of today's event. And now I'll give a brief introduction of Madam. Madam received her BTech degree in Electrical and Electronics Engineering from JNTU Hyderabad in 1993. MTech in Power Systems from JNTU Hyderabad in 2003, and PhD in Electrical Engineering from JNTU Anantapur in 2012. She has over 22 years of teaching experience in different cadres in JNTU Anantapur. During her tenure, she served as Deputy Warden for Ladies Hostel, NSS Program Officer, Head of the Department, Vice Principal, and now serving as a Principal of JNTU College of Engineering, Anantapur. She has over 12 years of research experience, and her research interests are power systems and energy management. 15 research scholars were awarded their PhD degrees under her supervision, and now 5 research scholars are pursuing their PhDs. She had published over 123 research articles in different international national conferences and journals. To her credit, one textbook got published with the title FPGA SHE Control of CMLI Using Stochastic Optimization Techniques in December 2017. She had applied for 2 patents on solar effluent treating system and silkworm pupae solar dehydrator. Now I request Madam to speak few words. Madam.
Good morning, Amma. Sorry. Good morning. Good morning, one and all. The management of GATE Institute of Technology, founder late Sudhir Reddy Garu, always a memorable personality, dynamic personality, Raghunatha Reddy Garu, and managing director Vani Garu, correspondent Padmavati Auntie Garu, principal of the college Dr. Venkatesh, and today's eminent speaker Dr. B. Muruganatham Balakrishnan Sar Garu, head of the EEE department and convener of the FDP Paramesh Garu, co-convener Shivareddy, senior faculty members of EEE department Saraya Suraya, eminent speakers from various prestigious colleges and NITs, other faculty members of GATE Institute of Technology, and my own student Daniel Odake from my college. Participants, good morning to you all. It's my pleasure to attend the inaugural function of a 5-day online FDP on recent advances in electrical engineering as a chief guest. It seems almost 20 years of association I have with GATE Institute of Technology. That is right from the inception of the college. Sudhir Reddy uncle is very known to me. He is a very nice person, and auntie is also very known to me. Thank you, auntie, for giving me this opportunity and inviting for this. I have attended for many programs organized by GATE Institute of Technology in the past few years in various capacities. I think a few months back, I have attended as a judge for some student even in online, if I am right. In my point of view, GATE Institute of Technology is one of the good choice for the students and always looking forward to adapt new changes in the present era. The title of the program itself, it is Recent Advances in Electrical Engineering, will give the insight objectives of this FDP. I think this FDP will cover various emerging areas related to the field of electrical engineering. In recent times, few areas of electrical engineering like smart grid technologies, electric vehicles, wearable technology, artificial intelligence, prefabricated products, IoT technology, robotics, augmented reality, role of big data analytics, uses of blockchain technologies, energy management systems, and many such have a lot of scope for research and innovatives. I think this FDP covers renewable energy sources and electric vehicles. In my view, there are no limits for research in all the above said areas. In recent times, interdisciplinary research activities are going on throughout the world. Integration of latest technologies like AI, blockchain with conventional designs is a common thing. Anyway, the eminent speakers will give complete details about different trending topics in the electrical engineering domain. These types of FDPs are very helpful for the faculty members to create their objectives for research and improve their knowledge in recent technologies. Today, as a team, we inaugurate a 5-day online faculty development program organized by Department of EEE, GATE Institute of Technology. This program features well-established facilitators with vast experience and knowledge in the electrical and electronics field. It's without a doubt that we are going to have a very informative program around the subject of recent advances in electrical engineering. The recent dispensation has graced us with a host of advances in the field of electrical and electronic engineering. These leaps range from transport, medical, consumer, and industrial domains. Today, we can confidently agree that the success of electrical vehicles is evidence that so much has transpired in these fields. Electric vehicles have steadily been gaining in popularity, and they are almost certainly the vehicles of the future because of their energy efficiency and reduced carbon emissions. Smart grids are, without question, one of the advances we get to enjoy today. More commercial and industrial consumers can generate their own power and even sell their surplus. This development has changed electrical delivery infrastructure and part with the advent of smart grids. Perhaps most importantly, the smart grid has allowed for communication between the power generation company, distributors, and end users, and helps boost efficiency and lower cost by facilitating a quick resolution of any issues. Another advancement worth noting is the graphene supercapacitors. A supercapacitor, which can often store almost as much energy as a lithium-ion battery, offers the advantages of increased energy storage. Graphene helps enhance supercapacitor because it is exponentially conductive, so graphene supercapacitors are ideal for high frequency applications, whereas traditional capacitors are not. Graphene allows for structuring and scaling down, so it has applications in computer processing units and integrated circuits, while standard capacitor materials do not. Today, we are surrounded by and utilize wearable consumer devices. Wireless technology has been making exciting advances. Smartwatches and similar devices help users monitor their health and athletic performance. Wireless technology, often Bluetooth, low energy, means these devices can be smaller and more convenient to use because they run on smaller, longer lasting batteries. Innovations in wearable devices also have life-saving potential in industrial applications. These innovations dramatically increase electrical engineers' safety on the job. Understanding the dynamics of the electrical and electronics field, we can attest to the fact that quite a lot is being discovered, redefined, and invented day by day. This program gives the stories to familiarize ourselves with the changes, developments, and innovations that have been realized in the recent times, with key emphasis on the need for continuity, reusability, consistency, and sustainability. We are able to establish that the world needs us to remain as relevant. We can, if we ought to stand a chance against the concerning challenges of climatic change, energy crisis, to name a few. In the spirit of significance and relevance, I call us of today imploring on the very same thing that rise we do the notability of our profession, asking that we seize this opportunity and climb one more step towards ensuring that we can deliver to the best of our abilities once again, as well as we remain relevant to our field and our students. I request all of us to ensure that we enroll for the program and up our skills even more. Well, it's my hope that this program will run as it is intended and that in these 5 days, we'll all benefit exponentially from the program, emerging better, empowered, and full of will. May we all find the excitement we look for and a renewal of our zeal towards this noble profession and pursuit. Thank you all and have a wonderful faculty development initiative. I hope this FDP will enable all of you to get some knowledge about various trends, and I wish all you for fruitful sessions. I congratulate the Department of EEE for organizing this FDP on a very good topic. Thank you one and all for giving me this opportunity and have a great day. Thank you, Jai Hind. Thank you.
Thank you very much, madam. Thank you for giving us the insight of recent advances in electrical engineering topics. And we hope we will have all the stimulating sessions. We'll make use of those stimulating sessions, and we'll pass it on to our next generations. And thank you very much for your inspiring words. And we are very thankful that you accepted our request and graced this occasion in spite of your busy schedule. Thank you, ma'am.
You're always welcome.
Thank you. And now it's time to introduce today's speaker. I request Mr. Lakshminath sir to introduce our today's speaker.
Thank you, madam. Good morning, one and all. I am M. Lakshminath, Assistant Professor, Department of EEE. I take this opportunity to invite an intellectual, Dr. B. Muruganandam, Registrar and Professor, Master Group of Institutions, MAM College of Engineering and Technology, Department of EEE, Tiruchirappalli, Tamil Nadu. Sir completed his BTech in Electrical and Electronics Engineering from NIT Tiruchirappalli in 2004, ME in Power Systems Engineering from Anna University in 2011, and PhD in Electrical Engineering from Pondicherry Central University in 2019. He has over 20 years of teaching, industrial, and research experience. Sir has abundant knowledge on various research areas like distribution load flow studies, integration of DER in the distribution grid, power system reconstructing, smart grid, and power quality. His publications speak about his experience and interest in research. To his credit, he has 10 international journals and 8 international conferences. He has received research grants like DST research grant received to a tune of 5 crores, AICTE RPS for 23 lakhs. He is a lifetime member in ISCE. Also, he is a member, and presently he has student advisor under ISA South India section in ISA USA. He is a reviewer in various journals, awarded as recognized reviewer and outstanding reviewer EPES elsewhere. He has published a patent with Government of India Intellectual Property, Controller General of Patents, Designs and Trademarks, titled EV Monitoring System, that is Real-Time Monitoring System in Electrical Vehicles using IoT-based technology. I welcome Dr. B. Muruganandam sir to take over this session and enlighten us with his experience. Thank you, sir. The session is all yours.
Thank you. Thank you. Respected Sujata madam. So previously when I was associated with the Gates Institute of Technology, I had admired on the works what madam has done, and madam was introduced by Syed Suraya madam when I was there. And our beloved Gates principal, correspondent madam, and the entire faculty team of electrical engineering led by Professor Paramesh. So very happy to be associated again with you all in this August gathering on the FDP 5-day online FDP on the recent advances on electrical engineering. So I will share my screen. Can you?
Yes, sir. Yes, sir. You can, sir.
I think the host has to enable me.
Now, sir?
Yes. Yes, sir. Yes.
Now you can share.
Yes, sir. Yes. Is my screen visible?
Yes, sir.
Yes.
Madam?
Yes, sir.
Very nice. So the topic what I have chosen is the importance of power systems research in the advancement of the society. So as my supervisor, Dr. Jnanadas, who has told me that unless we do a research which is helpful for the society, it is of no use. So we always take the society to be connected to our research so that that research will become useful to the society and also the mankind. So I am Dr. B. Muruganandam. I am the Registrar of Master Group of Institutions and Professor at EEE of MAM College of Engineering and Technology, here to give my session with the objectives of, at the end of the session, the learners will be able to demonstrate the different real-time research opportunities available in power systems, and they will be able to apply the power system tool to analyze a network and to illustrate the different funding opportunities which are available, and to interpret the societal impact and research and choose the field of research appropriately. So my content will go through research areas in power systems, the AI techniques, the load flow analysis, the smart cities and energy conservation, the demand response, and the AI techniques in energy price prediction, AC/DC microgrid and the energy market, and the AI techniques which is used in the energy theft, and the research with societal impact. And I have a small introduction about the GridLab-D software, which will be very useful for the distribution energy studies, and finally with the funding opportunities. So coming to the research areas in power systems, you have a broad classification with 4 areas. First one comes with the distribution network analysis, where you will be having the PV penetration or the distributed energy resources penetration and the load flow studies. And finally, with more PV penetration and the other distributed energy resources being penetrated, the harmonic analysis becomes a very important component in today's research. Next is the demand response, where we have single and multiple home demand responses, network integrated demand responses, and here due to the demand response to be forecasted, the solar, PV, wind, and the electricity prices which need to be forecasted. So coming towards the AC/DC microgrid, as rightly pointed out by our HOD Parameshwar, battery energy management is very, very important now, and also the bidirectional converters are taking place in a very nice manner. So many researches are happening in AC/DC microgrids. Finally, the electricity market. So here we need to strategize the bidding for all the distributed energy resources, and we need to have an effective demand response in the markets. So this is how my today's session will take place in 4 different areas. So coming to the topic machine learning, nowadays, if you go outside and to speak with somebody, as rightly pointed out by our chief guest, Sujata Madam, that nowadays the research has to be interdisciplinary. So when you go and talk to someone, everyone in the world now speaks about machine learning. They speak about deep learning. They wanted to know some regression methodologies. So many techniques which is being spoken outside, and the electrical engineers are scared to know what is happening, why it is all spoken now, why machine learning now, why Python programming is being taken into a good programming nowadays. So we are all scared. But if you do interdisciplinary research, your research, which is a solar irradiance prediction models, can be used with machine learning techniques, and this will lead to wonders. So what is the use of this? Past weather data and the parameters, temperature, wind speed, atmospheric pressure, humidity, and predicts solar irradiance. These all need to have been done a deep learning, so that which will be used in your efficiency improvement. So this will help the grid operators for improved supply and demand management. If you know how your solar irradiance is going to have, how your temperature is going to differ, what will be the atmospheric pressure. So based on that, you can have a detailed study about the different distributed energy resources which has been integrated in your distribution system, and you can make a more efficient way of doing supply and demand management. So you can see the evaluation of the complete solar. See, we have monocrystalline, polycrystalline, and thin film technology. And you can see the price got reduced, and you can see the efficiency in percentage, and you can see the lifespan in years. So in this comparison, you can see that the solar panel efficiency has not reached even 30%. In certain cases, it has gone up to 42%. But the ground reality, where we are using our solar panels, the average percentage generation of solar panels have never crossed 15%. And you can see the way the evolution of wind turbines have increased. So the heights have increased, the output have increased, but still the wind efficiency has not reached 40%. So what's happening? You need to have some more techniques to analyze. So even 1% increase in your production, 1% increase in your production will give a remarkable output in the energy. So continuously, the ANN techniques, the AI mod techniques, and the ANN models have been characterized to increase the reliability of renewable energy plants. So this tool will improve the efficiency, and in this capital intensive sector, any minimal efficiency improvement in energy production could represent more economic savings in future business plans. So this is very crucial to have an interdisciplinary research immediately, so that a computer science engineer will come and talk about what they know. And you will be talking about the solar, the renewable integration, the power electronics, the power systems. And if you both sit together and if you discuss, there will be an emerging research which will come out with an excellent solution where the computer science, the electrical engineering, the electronics engineering all will combine, and there will be a solution for the problem which is existing. So let me give some introduction about the present trend in AI techniques which is used in PV penetration. You can see the photovoltaic plant predictive maintenance optimization is being done using the AI technique. So what they are doing, they are detecting and classifying anomalies, predicting the failures, and they are scheduling the maintenance activities. So what happens if you do a predictive maintenance? The long-term financial performance of solar power plants will get increased, and the reduced downtime can be achieved. So using AI technique, the photovoltaic maintenance optimization has been done. Then the advanced metering infrastructure which we are having now, the government of India has approached towards changing the complete energy meters into smart meters. The pilot project was established in the year 2007 in Pondicherry, and now they have taken to the entire subcontinent India. Both Andhra Pradesh government and the Tamil Nadu government has told that in another 3 years, in a phased manner, the entire domestic energy meters will be converted into smart meters. So what happens? We are having an advanced metering infrastructure, and PMU data is completely being given. So we are going to integrate this advanced metering infrastructure to boost the renewable penetration. So what happens? What we are doing here, we are synchronizing, we are cleaning up and interpolate electric data with from numerous sources, and we are accurately estimating the state of electric grid. So what will happen? This will ultimately allow for the interconnection and operation of more voltaic systems and other distributed energy resources in power systems, and it enhances the reliability, resilience, and the power quality. So the integration of the advanced metering infrastructure with the different data which is emerging from the grid, and if you operate the grid with more and more accuracy, your reliability get increased. So this is another technique where the PV penetration uses the AI techniques. Then the third one is improving grid awareness by empowering utilities. So the utilities previously, they were all having older techniques. So simply if there is any breakdown, they have n number of reasons to tell. But now it is not like that. The grid operators and the engineers have to do real-time analysis, and visualization capabilities are being given. So you can see the SCADA has been now extended to the distribution system. The distribution system SCADA can even go inside your house and see what type of load you are using at this instant. So when more number of data is being pumped, the cloud computing is again a challenge. So it approaches the system monitoring and the real-time analytics, providing a model leveraging multiple data sources to correlate, verify, and interpret a system. So what is happening? Telemetry comes into picture, and the environments with high scale and low data fidelity happens. So you need to empower the utilities to do a real-time analysis, and they should have more visualization capabilities. So SCADA is being extended to distribution. All your distribution transformers are being now maintained and monitored. Next one is loss rate. The biggest challenge for growing countries like India is the line losses. The line losses is almost around 27% of an average in all over the India. And because of this line losses, you cannot forecast how demand is going to increase. So to analyze the data from a large number of neighboring photovoltaic systems, in order to extract information about their short and long-term performance, you need to know how the loss rate is going to happen. You need to have an intelligent power forecasting technique so that your demand and supply can be met out when distributed energy resources are used. Then the next is the deep learning technique. Deep learning, net load forecasting, and enhanced behind the meter PV visibility. So what is happening? It is to predict the electric load one day in advance in areas that have large amounts of behind the meter solar. That information will allow operators to manage the electric grid more efficiently and cost effectively. So the deep learning powered probabilistic forecasting framework will give day-ahead net load at substations and will separate behind the meter photovoltaic generation from net load measurements and qualify its impact on net load patterns. So the load patterns will be very clear. Based on the load patterns, using the AI techniques, you can predict what will be your demand and what will be your supply, and based on that you can attach each other. So these are the glimpses of some AI techniques which is used in PV penetration. So for all these, to have an excellent distributed load flow analysis, it is needed so that the electrical performance of the network can be analyzed properly. So we have Newton-Raphson method, Gauss-Seidel method, stochastic searching techniques were used, genetic algorithms were used, and came the forward-backward sweep algorithm, which is more suitable for a radial system. And now we have advanced forward-backward sweep algorithms also. So this is an iterative method which has two sets of recursive equations. The first set of equations calculate the power flow through the branches, and the other set of equations calculates the voltage, magnitude, and angle. And this is illustrated using a small 4-node system. So the power is calculated from the end node to the root node. So it is a backward sweep, and then the nodal voltages are calculated to have a forward backward load flow analysis. So here FBS, why it is more popular? It uses only Kirchhoff's voltage and current law for calculations. There is no complications like Jacobian matrix inversions like that. And there is no singularity problem. Faster convergence, the computational complexity is less. So the smart cities are the next important thing. As Sujata madam pointed out, the smart grid infrastructure and the policy of the government towards smart cities have emerged the researchers to do more research towards smart cities. So let me illustrate. You go through this diagram. you can see I have taken a topic, effective utilization of solar power in urban distribution system. So based on the diagrams, you can see the post office, banks are there on one side, supermarket, schools, hotels, like that I have segregated. So from this diagram, you can segregate the load into two loads. If you take the post office, bank, the schools, colleges, these are all called as day loads. And most of the domestic areas, you have night load. In supermarkets, you have both day and night loads. So if you take a typical demand curve, which is a mixed urban demand curve, so this is the household, this orange colored line is the household alone. So the blue colored is the household and service sector. So what do you mean by service sector? Like supermarket, hotels and all, they will have a service sector. So we call these loads as homogeneous loads and heterogeneous loads. So for illustration, I have taken a typical homogeneous load, which is a house. It is only the residence. These loads have a cumulative annual load pattern. So you can see here, this heterogeneous loads, at the ground floor, they have shopping complexes. And at the first and second floor, they have residential sectors. So it is a combination of both residential and service sectors. So these loads have a different load patterns considerably. These load profile are different and are large enough to lead to significant differences in renewable power integration. So I'm going to take this two types of loads to a renewable power integration. So always, if you see the power system researchers, they will always refer the IEEE standard buses. They will work on the IEEE standard buses and they will publish papers on the IEEE standard buses. This is how all the Indian researchers are doing. But my supervisor is always wanted to do something to India. So he has created many Indian bus systems and he has made it as standard bus systems, and we will work mostly on the Indian networks. So this is a typical area of Pondicherry White Town, where this White Town comes from because during the previous Dutch, French and British era, only the white people are allowed to be here. So here you can see this is the office area where you will have the Taluk office, the French Institute, the Chief Secretariat, all are the office sector. And a small part of residence area, a small part of worship area, and entire beach has the commercial area. So it is a complete busy network. So this system has been converted into our single line diagram, where it has a combination of spot loads and it is having a distribution transformers and various data have been given. So as it is having the Chief Secretariat office of Pondicherry, this feeder is called as Pondicherry Chief Secretariat feeder. So for illustration, this network has been divided with heterogeneous and homogeneous loads. So you can see shops are there, malls are there, temple is there, complete office is there. So what I made is D represents day loads and DN represents day and night loads. And this is the complete beach side where you have complete lighting system. So only during night this beach has been glorified with lights. So what we are going to tell from this network is, see, I have given you two birds here. One bird is the owl, which is called as nocturnal. It is active at night and it will sleep during the daytime. All other birds, they are active during the daytime and they will sleep at night, which are called as diurnal. So we have combined this characteristics with the solar. Solar is active only during the day and it is not available during the night time. So based on this, we have combined both diurnal and nocturnal characteristics, and we have created a new load factor called as diurnal load factor. So this is defined as a ratio between average load during the daytime, which is 8 a.m. to 5 p.m. and to the peak load occurring on that period of the network. So this diurnal load factor, now I have segregated the loads into diurnal loads and diurnal and nocturnal loads. And now when you use solar, if you choose the node which is having more diurnal loads, and if solar is integrated in that particular node, then the efficiency is increased. So we have calculated the diurnal load factor, and wherever the load factor, diurnal load factor is higher, we have chosen and we integrated solar and we ran the load flow studies. And this load flow studies gave us good results, telling that when you choose the diurnal load factor and if you integrate the solar in these nodes, the entire efficiency, the utilization of the solar power during daytime is more. So this study was submitted as a report to the Pondicherry Chief Minister, and immediately when they integrated the solar in the beach side, they have chosen the nodes which we have suggested, and that was implemented. So this is how the society problem has to get analyzed. You need to analyze, you need to go and live with the society, discuss with them what type of problem they are having. And if you are able to give a solution to that problem through your research, then that is the successful research. See, for example, the Fujisawa Sustainable Smart Town in Japan, where 100% solar is being integrated and green energy is being used. They have the complete, the city, entire city is planned such a way that it uses most of the day load using solar, and very rarely they depend on the grid power. The next important activity of Indian smart cities is the energy conservation. So the Indian smart cities have a theme with active energy efficiency, affordable and reliable technology, optimum energy utilization, and management of resources. So here, a typical cooling system which is used in Indian smart cities, I would like to touch upon. So you know that nowadays, when you want to have a smart infrastructure, the temperature or the cooling system should be more effective, and you want the entire area to be a centralized cooling system. In order to have a centralized cooling system, the smart cities are being adopted with technology where you have a different cooling mechanism, which is called as the central cooling mechanism, which is being adopted in smart cities. So what they have a recycling model with snow, wood chips, which will not allow the external heat to pass on. And then they have various stages where the filtering, the separator, the pump, the self-killing mechanism, and you have a heat exchanger so that a reduced temperature air is being blown to the buildings and it gets recycled. So this is another important central cooling system which is adopted for the entire city. So the smart cities will have this type of central cooling system where the water recycling happens and cooling is also being done. So the next research topic, what I thought I will choose is the demand response. So nowadays, the demand response, the DSM, all these techniques have been taught in the college itself as a subject. So what is happening here? It changes the electrical usage by end use customers from their normal consumption patterns. So you are going to change the response or the normal consumption patterns of a customer from one way to another, so that what happens? It lowers the electricity uses when the prices are higher. When the demand is more, you are not attracting the customers to choose the load. So what happens? Their pattern gets shifted, and whenever the prices are higher, the customers are not availing the power, automatically your peak demand gets reduced and your system reliability gets increased. So what are the features? Temporary reduction in consumption, reduction targeted at a few specific hours, and may be associated with curtailment of service. So you know that in many of the states, when the summer season starts, the supply is less and the demand is more. So the utilities will start curtailing the power for 1 hour. For the past 2-3 years, the curtailment of power is not there in urban areas, but you can see in village areas where more number of power cuts will be there. This is why the visionary, our Sudhir Reddy Garu, made the Gates Institute of Technology to use only the green power and not depend on the grid power, because Gutti village experienced frequent power cuts and the students were highly affected to do their laboratories. So he decided that the entire institution will work only in the solar power and will not or very leastly depend on the grid power. Next, what is the need for this demand response? You can see here in this demand curve, during the peak demand, only there is a shortage of 100 megawatt. But do you know, for installing a 100 megawatt thermal power plant, you need 600 crores. For installing a solar power plant of 100 megawatt, you need 460 crores. And to install a 100 megawatt wind power plant, you need 700 crores. So just to have a 100 megawatt of increase for not more than 3 hours, do our country need to install a capacity which is of crores and crores of money, which can be used in some other good deed? So that is why the demand response came. So what we need to do? We need to change the demand so that this shifting will help us not to install this 100 megawatt in our power plants. So what we are doing, we are reducing or shifting the demand. So the demand gets reduced. So the price gets reduced. How price has been connected? This is a case study which has been taken from Mumbai demand. See, up to this curve, the Tata Power is supplying. So you need to do some external power purchase only during the typical demand. So Mumbai needs to procure 800 megawatt of power in the daytime peak. So large distortion in peak and off-peak power requirement happens. So if demand response is being activated properly, you can easily overcome this problem. So you have a morning peak, you have a day lean, and you have an evening peak. So this is the typical Indian load curve. And this is the bulk customers load curve and residential load curve, which is taken for illustration. So let us take that This load curve is a domestic load curve. If you go and tell to your mother that if you operate your washing machine at 1 o'clock, you will be charged 0 paise. Never before your mother will start the washing machine. She will only operate when there is no paise. This is our typical mother. And if you tell that if you operate the air conditioner when it is 10 o'clock, you will be charged 18 rupees per unit. And when you operate the air conditioner after 12 o'clock, you will be given 2 rupees from grid. Your mother will switch on the air conditioner only after 12 o'clock. So easily, the behavior of the customers can be changed if you have a pricing called time of use tariff. So this time of use tariff is going to come, and it has been adopted in many countries. So whenever there is an off peak from 8 p.m. to 7 a.m. in the morning, your energy charges is 10 paise. And when there is a mid-range, it is 14 paise. And when there is a peak, it is 30 paise. It is just for illustration. So what happens during the low demand season, there is one pricing. And when there is high demand season, there is another pricing. So what will happen? We will choose the green phase so that our tariff will not get increased. And we are helping the utility to maintain the demand. So this time of use tariff is a very important component for researchers to explore how the demand response can be made more effective. So what happened? Because of time of use tariff, the most benefited people are the electric vehicle people. Whoever is having an electric vehicle, see what they will do? They will connect their smart charger to the charging unit and they will keep quiet. What will happen? See, their smart chargers will charge whenever the demand is green in color. It means the cost is almost zero, or sometimes it is in negative also. And whenever it sees yellow color, the electric vehicle will start discharging towards the grid and it will gain cost from the grid. So when there is no cost or negative cost, the vehicles will get charged, and when the cost is high, the vehicle will discharge to the grid and it will generate money to the owner. So simply by connecting your electric vehicle with smart chargers, you can help the utility to maintain the demand response, and also you can help them to have green power and you will get money. So these are all in Germany, almost around 3 lakhs electric vehicles are connected during their evening peak demand. And this helps the utility not investing more during the peak demand, and they get power from the customers themselves. So this is one of the important research area which is going on nowadays. So solar charging stations are being increased day by day so that the electric vehicles gets charged when they are parked. So most probably in another 2-3 years, all the faculty of Gates Institute of Technology will bring their cars, electric cars, charge, and then when they are going home, they will go with free of cost. So this is how the technology is being emerged, and electric vehicle charging stations. And now the government of India has told that there is no formal approval is needed to set up a charging stations in the highways, entire India. Wherever you have space, you can set up an electric charging station and the electric vehicles can get charged over there. So the emerging trends have gone likewise, and the time of use tariff could halve the peak loads with use of electric vehicles. So this is what has been already illustrated. So next is the energy market. How the AI techniques is going to be used in energy price prediction. So I will stop here for any questions, because it should not be a monotonous way of going. Yes, audience. Shall I proceed? Okay. So the AI techniques in energy price prediction, you know that electricity is a special commodity. Trading is a great risk because it cannot be stored. It all depends upon the weather, the temperature, precipitation, wind power, etc. And it has a different load pattern. Weekdays has a different load pattern. Off weekdays, you have a different load patterns. And the price continuously varies. And you know about the fossil fuels, which is not there, which is diminishing. And the maintenance cost is also an influencing factor. So it gets changed again and again. So what happens? Nowadays, AI techniques have been implemented and they do a complete search techniques. And because of this AI techniques, when there is a prediction being given that they will do a long-term forecast, they will do a short-term forecast. And during the long-term forecast and short-term forecast, they will find out when the power drop will come. The price of the power, when it drops, if you buy, then you'll have good economic value. So this is how the energy price prediction is done by AI techniques. So what they are doing, they do data mining. In data mining, wavelet analysis, LSSVM models, fuzzy sets, chaos-based theory models are being done. And in time series analysis, linear regression, stochastics, and nonlinear heuristic techniques are all being done. And for simulation using game theory and production cost method, the energy price prediction is being done. Next important topic is AC-DC microgrid. In AC-DC microgrid, you can see here the wind turbine, diesel generator, the AC load, DC load are all comes under the AC network. So what happens? Here you have an AC input, which has been converted into DC and used for DC load. And on the other side, you have a PV, the energy storage. All of these are all DC network. So what happens? You can have both AC and DC microgrid. And now the technology has gone towards the DC microgrid. If you visit IIT Roorkee, they have developed a lab where the complete domestic appliances are being converted or are being designed as DC. They have a DC refrigerator, DC air cooler. They have a DC, air conditioning unit, complete DC. They don't have AC at all. So they have developed a complete lab, which is called as a DC microgrid lab. So future is going to come as you will be having a AC line separately and you will be having DC line separately. If you take your laptop is a DC, your LED TV is DC, your mobile phones are DC. So almost all loads, what you are using are DC. And today in today's Hindu newspaper, Tirumala Devasthanam has told that almost they are going to convert 5,000 ceiling fans into BLDC fans. You know, after converting this 5,000 fans into BLDC fans, they will get a revenue benefit of 67 lakhs per annum. See, the investment is very less, but when a BLDC, high efficiency, low power consumption BLDC fans are used, they will get a revenue of 67 lakhs. That way, the complete household domestic things are going to get converted into a DC grid. So what will happen in future? See, you have a charger for your laptop, which converts the AC into DC and then gets charged. That conversion wastage can be reduced. Your mobile phone again has a charger, which has a conversion kit. That conversion wastage can be reduced. So in future, DC microgrid is going to emerge as a very big place where the researchers can play around and form so many things which is going to happen in microgrid. So you will have a distributed generation, distribution and management, and smart consumption. So distributed generation will have more distributed energy resources, and the grid operation and transmission will happen with a proper management. And you know, smarter consumption with electric vehicles, storage devices, smart meters, solar panels, all these things will come into picture. So here, the researchers have different ideas: the distributed energy management, distributed grid intelligence, and smart prosumers. So why we are calling it as prosumer? Because both production and consumption happens on the same time. So you become the prosumers. So the different areas where you will have the research topics is mentioned here, starting from DER integration, demand supply forecasting, independent system operator challenges, data storage, home energy management system. All these things are all comes as the state of art of intelligence techniques for distributed smart grids. So if you go depth into these techniques, so many AI techniques comes into progress. So as a researcher from electrical department, you can integrate with the other departments and you can do an excellent and wonderful research. So coming back to the electricity market, artificial intelligence is helping compress and analyze the massive amount of data, n number of data. You know, from smart meter, we get 72 electrical parameters. So in Google, in March 2017, they have acquired an AI company called DeepMind, and the UK's National Grid. What they are going to do, they are going to add artificial intelligence techniques to the country's electricity system. So this project will process massive amount of information from weather forecast to internet searches, and they will develop predictive models. So this is how artificial intelligence technique has entered into the electricity model. So they have come out with a plan called Grid Edge. So what this Grid Edge is going to do, it is having end-to-end VPN, which will communicate with your building, energy, and environment, and they will predict whether any fault is going to occur, or you need to do any optimization, or you need to do any controlling over there. And this SaaS model will come back to the grid, and this will create financial savings, and it will produce a flexible demand side payments. So this will get a high grid stability, which is called as the active network management, and solid peak load management, reliable voltage regulation, and wide range of individual functionalities, real-time evaluation, automation, intuitive operation, modular, and it will be very scalable also. So this A&M adjusts grid's responsibility with the energy producers and available for solar parks. So when more data is being transferred in terms of transmission and distribution, this big data and AI applications combines together and again creates more data integrated, data generated system. And this data has to be optimized in the electrical market operation. And this is another research topic. So finally, this AI application is also used to find the energy theft, especially in developing countries. The line loss or the line drop is almost the energy theft, which cannot be identified. So direct hookup will happen, physical obstruction, bypassing the energy meter, damage to the electric meter, then external chip is being injected. So many corrupted activities are being happening. So the consumers steal electricity, political interference will be there. So in order to overcome all these things, to have a proper accountability, this cyber attacking billing systems, AI applications will identify the energy theft. So power companies are now using AI tools to identify customers whose build pattern of those does not match their total power consumption. So now what happens when AI tools comes into picture? What are all the load is operated in that network is being easily deductible, and they find out what are all the ways to identify the energy theft. So having all these things, we have a smart power network so that you will have a network optimizer, consumer, producer with many AI modules, and you will create a smart power network. So this smart power network will predictive maintenance control of AI. It is maintenance models are easy to understand, and you will do conditional monitoring, and many limits, alerts can be easily set, and using the edge computing, the data acquisition, storage, and decision support can be done easily at the load level itself. And this AI helps to adopt the power plant autonomous maintenance and controls the grid station. So this is one of the important things. So coming to the final topic, where research leads to a societal impact. See, curiosity leads to research. Research is what propels humanity forward. It's fueled by curiosity. We get curious, ask questions, and immerse ourselves in discovering everything there is to know. Learning is thriving. So, research evaluation exercises as conducted by funding bodies are sharpening their expectations that our research should have demonstrable impact in the form of societal value. So for instance, in the developing countries, research assessment exercise specifies 15% of the research assessment will be attributed to the impact towards the society. So impact here is defined as the demonstrable contribution, beneficial effects, valuable changes or advantages that research qualitatively brings to the economy, society, culture, public policy or services, health, the environment or quality of the life that are beyond the academia. So any research when you do, as I told earlier, before selecting the topic, go to the society, get the feedback, not only from the experts, but also the samples of the people in the society. Conduct a survey, collect the data, and analyze and interpret it considering the societal implications. Last year, we have written a project proposal for 1,400 crores in the complete tribal areas of Salem district in Tamil Nadu. So we took our management students and electrical students and we stayed there for 1 week and we talked with them, we lived with them, and we found their problems. And based on that, we have written a nice proposal where all the problems what we have arrived are given solutions to the 1,400 crores project. So this project, whether it has been sanctioned by DST or not, what we found was there are many problems where technological experts can give societal impact on the research. Through their research, they can give some solutions to them. So one example which we carried out again in Pondicherry is one feeder. Very fastly, I will complete this. This is called as Pillai feeder, which serves the Pondicherry Central University and the entire village, which has been near to the Pondicherry Central University. So the distribution was around total kilometers was 3 kilometers. So you can see here there are both spot loads and distributed loads. So SS is substation, your distribution transformers. So around 17 substations, that is the distribution transformers were there. So this blue colored lines are HT consumers, the spot loads, and the other stars are all distributed loads. So we have run the power flow using GridLab-D, and we found that certain nodes are overloaded. So you can see here, these transformer 12, transformer 3 is overloaded, and when we went on and we completely ran the load flow, we found that 11, 10 and 7 are underloaded. Not even 10% of the transformer was loaded. So you know that when the transformer is underloaded, again, the efficiency gets reduced. So we did a reconfiguration analysis. So connection 1, connection 2 was suggested, connection 3 and connection 4 was done, and based on that, the load flow was again ran. So this we called as energy loss reduction and load balancing, and this paper is already published, and we found that 2 transformers can be made as underloaded, or the load can be reduced by properly reconfiguring. So finally, what happened? This report was submitted again to the Electricity Department of Pondicherry, and this connection 3 was there till here, and it was established, and a new transformer was introduced in this connection 3, so that these 2 transformers 12 and 3 got underloaded. So immediately the Pondicherry Electricity Department, they took our suggestions, they came and did a survey, and they connected this connection 3 and they installed one more transformer, and all the other transformers were now working properly. So whenever we are crossing that new transformer which has been installed, when we see there, we feel that our research have created a societal impact. So this is how the research has to given back to the society. So this rural livelihood transformation by converting the auto rickshaws to electric rickshaws, recently we got a research promotion scheme for the same title for 23 lakhs. And all the others also we got. And these are all the DST projects which we have got through societal impact. So as mentioned, GridLab-D is a very important tool which is developed by IEEE, and it is explained very clearly how a distribution load flow analysis can be done. So I have given these slides, I will share these slides so that in future, when you are doing research, you can learn GridLabD and use the same tool, which is an open source tool. You need not pay anything, and you can do wonderful research in using these tools. So let me touch upon the funding opportunities which are available with the DST. So presently the DST SERB, the core research grant is April 18th is the last date. So you can apply for a core research grant. And if it is, you are having any research ideas or problems or solutions, and whenever you write, connect your research with the societal impact and write. So a SERB fund for industrial research engagement is there. I think tomorrow is the last date for these. So you need not touch that. But the schemes opened throughout the year. You can use the international travel support. You can apply for any conferences abroad. You can apply for funding. J.C. Bose National Fellowship. This can be done for the physics department, Ramanujam Fellowship for maths department. And throughout the year, you can apply for seminar and symposia, SERB Power Fellowship, and Vajra. These are all very popular fellowships. And upcoming calls, which opens only after April, is the SUPRA, Scientific and Useful Profound Research Advancement, and the NPDF, Empowerment and Equity Opportunities for Excellence in Science, and Technological Translation Award, International Research Experience again, and National Science Chair and SERB Power Grant. So National Mission on Interdisciplinary Cyber Physical Systems, ICPS, is also a very important research where you can get enormous fund on the interdisciplinary cyber physical system, where you can coordinate with the computer science faculty and an ECE faculty and write research on cyber physical systems. And this interdisciplinary systems have enormous fund which has been available with them, but only very little people are applying. Whoever is applying, they will get fund on this. And here in this ICPS, artificial intelligence, IoT, data banks, advanced communication system, robotics, cybersecurity, physical infrastructure, these things are all the core areas. Coming to DST, the STEM demonstration, innovation and demonstration, these are all open throughout the year. The proposals which are open throughout the year means that fund is available and only very less people are showing their interest towards these proposals. Then technological interventions for disabled and elderly program, call for applications for Asian India Research Training Fellowships, R&D proposals and Asia-India Science Technology Cooperation, Abdul Kalam Technological Innovation National Fellowship, and Research and Training Fellowships, Research Scientist Scheme, and announcement for inviting technologies, innovation, idea for support under Asian Indian S&T Development Fund. And extramural scheme, high risk, high reward research, empowerment and equity opportunities for excellence in science, startup research grant for young scientists, Ramanujam, already we have seen all these things. And the ongoing proposal is the 5th BRICS call for proposals, Indo-Danish call, and the schemes opened scheduled caste subplan, spatial data infrastructure, nanoscience, nanotechnology, and the scheduled caste subplan has a seed infrastructure for, especially for the scheduled caste students who are there more than numbers in an institution. I think Gates College can target this scheme. And science and technology, institutional and human capacity buildings, there are a number of programs. And you know that this policy research cell, this CORD proposals, Gates College have got more than 70 lakhs, this proposal in the year 2019. So this for DST research and development, there are many schemes. And innovation, technology development and deployment, we have schemes. And the ongoing call for DST schemes opened throughout the schemes, and AICT quality improvement scheme, as I mentioned, the research promotion scheme. If you write properly a research promotion scheme, 25 lakhs AICT is giving. Unnat Bharat Abhiyan is another, again, nice activity for the society. STTP, I received a STTP grant for 3.5 lakhs in the year 2020. So there are so many grants which are up there. If you keep on applying, 100%, you will be receiving at least 2 grants a year, so that it is a win-win situation. Your institution will grow and you will grow. So there are other India-centric research funds which has been given here. You can have a note of it, and I have also given the link so that you can go through the fundings in detail. So I hope the knowledge what I have been shared in this session. Thank you. Any questions?
Sir, from audience side, we have questions, sir.
Sure, sir.
How the solar car is different from normal electric vehicle, sir?
How the solar car is?
Differ from normal electric vehicles.
If your electric vehicle is powered by solar, it is a solar car. So you can see electric vehicles now comes with panels where whenever your vehicle is on the move, the solar light is being converted and it directly charges the electric vehicles. So normally electric vehicles are charged using a grid connected chargers or a solar unit which is external source. If your source is available in the car itself, then it is called a solar car.
Right, sir. Thank you, sir.
Any other questions?
Good morning, sir.
Good morning, sir. Tell me, sir.
Myself, Vinay, sir, from S University, research scholar.
Yes, sir.
Sir, from your presentation, I got one. I need one clarification, sir.
Yes.
Sir, that ANN, how far it is suitable to implement on energy and reliability other than optimization techniques?
See, I am not an optimization expert, but still I will tell you. Any
why?
technique.
Because, sir, why I got this means actually ANN is a learning risk process.
Yes.
And this all this energy production and reliability, it is changing with respect to time.
Yes.
So to optimize that one, is it suitable to implement this ANN other than optimization techniques? That's a small doubt. Clarification.
Sure. See, any optimization techniques can be implemented for the specific application, even in energy sector. See, energy production and energy distribution is different, but the control of the energy is again what you told us. ANN technique can be used, but if you want, you don't relate with the energy production and distribution. Controlling, wherever you want to control the energy, you can use ANN techniques, optimization.
Okay, sir. Right. Thank you, sir.
Thank you. Shiva sir, any other questions, sir?
No, sir. No, sir. Still no questions from the audience, sir.
So I will share my presentation. I have given my email ID and my phone number. You can always contact me for a discussion. So my suggestion is whenever you have a research problem or you are searching for a research problem, just go have a tea and have a chat with your other domain people who are experts. So you may have a problem. They will have an interdisciplinary solution so that both of you, if you do a research with an interdisciplinary way, the outcome is very nice. So nowadays, the computer science people, they know many techniques, but they don't know the applications. So when you talk about applications, they will be ready to help you in all the domains. So even when I am doing a research, we are doing a machine learning approach for identifying the problems in the distribution transformers. So if you go out to the utilities, whenever we go to the electricity department, the engineers will tell that, sir, this month alone, 40 distribution transformer got failed. So we are doing an analysis for distribution transformer failures using the machine learning and deep learning techniques. So for that, our computer science professor is helping me to do their part. So the load flow analysis I will be doing, they will be helping in the AI techniques. So combinedly, the outcome comes in a different way. So if you can easily identify when a distribution transformer will about to failure, and if you can do a predictive maintenance, that will be the success story of utility. So I hope that our faculty team can start research like that, more focus towards the interdisciplinary research, so which will lead to more funding as well as publications in future. So I thank Surya madam and Paramesh sir for giving me an opportunity to share the little knowledge what I have with my research.
Thank you, sir. Thank you very much for your valuable time, and you have shared whatever you have shared. It's a nice presentation. Sure, the faculty members who have followed you, I mean, your this session, they'll make use of this, and they'll apply for the grants. They'll get grants also. Hope for this. And thank you, sir. And I request Shiva Reddy sir to propose vote of thanks.
Thank you, Mr. Chopana. A very good afternoon to everyone present here. I hope you had a very interesting session. On behalf of Department of Electrical and Electronics Engineering, Gates Institute of Technology, and the audience, I am Shiva Reddy, deemed it a great honor and privilege to thank the speaker, Dr. Muruganandam sir, for all valuable info shared with us this present time. The lecture was as an interesting one. So thank you, sir. You had given a valuable, nice presentation and insight to all recent research topics of electrical engineering. So thank you for your valuable lecture, sir. I thank all the participants who registered and attended today's session. So thank you one and all. So now it's time to propose vote of thanks. On behalf of my team, today I take this opportunity to put all my gratitude in this form of words. So first of all, I would like to thank Chief Guest Professor Sujata Madam, who graced our FDP inaugural sessions and inspired us with her words. Thank you, ma'am. I would like to thank our distinguished speaker, Dr. Muruganandam sir, for making excellent presentation and making this session interesting and meaningful. I would like to extend my heartfelt thanks to our beloved correspondent, Srimati V.K. Padmavathamma Madam, for her encouraging words in inauguration session. And thank you, Madam. So I would like to express my gratitude to our Managing Director, Sri Raghunath Reddy sir. Thank you so much, sir, for supporting us, guiding us in right way. I would like to thank our Director, Srimati V.K. Srivani Madam, who has initiated us to do this program and her continuous support right from the inception. Thank you, Madam. I would like to express our profound gratitude to our principal, sir, Dr. Venkatesh, sir, for his consistent support and encouragement throughout the program. Thank you, sir. And I would like to thank all my colleagues who made this possible. Thank you, sir. Thank you so much, sir.
Thank you, sir.
Thank you, sir. Thank you, Shiva Reddy sir. Thank you, Muruganandam sir.
Thank you, ma'am.
Nice meeting you on this platform.
Sure, ma'am. It's
Thank
my
you.
pleasure to be associated with you all.
Yes. We are missing you a lot here. Thank you.
Thank you, ma'am.
Our association will be like this only.
Yes, ma'am.
Hope.
Yes, ma'am.
Thank you, sir. Thank you, participants. The feedback link is shared in the chat box. Please give the feedback for today's session, and kindly join us tomorrow for the next session. And tomorrow at 10:30 sharp, we'll start the second session. Thank you, one and all. We are closing.